In this video, I'm going to be talking about the sinusoidal voltage. And I will be using the household voltage of 120 volts RMS. Now, if you put your household voltage on an oscilloscope, it's going to give you a sinusoidal function like this. It will start off at 0 volts. It will go to a peak of 170 volts, goes back down to 0 volts, goes to a bottom peak of minus 170 volts, and then back to 0 volts. The total time it takes for this is 16.666 milliseconds. The frequency is 60 hertz. The period is 16.666 milliseconds. And the period equals 1 divided by 60 hertz. Now, it starts off at 0 volts, 0 degrees, and 0 seconds. The 120 volts occurs at 45 degrees, and 135 degrees, and 225 degrees, and 315 degrees. The positive half cycle is 8.333 milliseconds. The negative half cycle is also 8.333 milliseconds, for a total of 16.666 milliseconds. Now, over here is how these voltages are generated. These black dots is a conductor. It's really just one conductor moving through different places. These horizontal lines are called magnetic flux lines. As the conductor moves through the magnetic flux lines, it creates a voltage. These voltages is what creates the voltages here. It starts off at 0 degrees and it climbs to a peak of 90 degrees. At 90 degrees, you now have 170 volts. It continues through the positive half cycle all the way to 180 degrees, which is right here. At 180 degrees, the voltage is now 0 volts. It continues on to where now the voltages are negative. Now, the reason why the voltages are negative during this half cycle is because the current is now moving in the opposite direction. First it moves in one direction, then it moves in the opposite direction. So right here it's at 180 degrees. It continues down. Now you're at a peak down here at minus 170 volts, and it continues until it goes back to 0 volts. The frequency, as I stated, is 60 hertz. What that means is that this pattern repeats itself 60 times a second. And the total time for each pattern is 16.666 milliseconds. Now, the formula for finding any voltage at any angle is 170 volts, which is the peak voltage, times the sine of the angle. Or if you're going to use the time, you go 170 volts times the sine 2 pi times 60 hertz times t, and t is the time. The RMS voltage can also be determined by Vrms equals the peak voltage of 170 volts divided by the square root of 2. And that concludes the video. Like and share, and I'll see you in the next video.